Good afternoon, everyone. Thank you for joining us. My name is Matt Greeno. I'm the Director of Technical Services here at GRIDSMART. And today we're going to talk a little bit about best practices and troubleshooting. And we'll also look at some resources that are available for you as you guys are out in the field working with GRIDSMART and getting your intersections up and running. So I appreciate everybody's participation. We will have Q&A at the end of the presentation, and feel free to use the chat functionality of this webinar. And also there's a Q&A board as well. So if you have questions, you can post those up as well. And I've got a couple of people here helping me out today, so they will try to answer those questions in real time. So hopefully you'll get what you need. So without further ado, we'll go ahead and get started. Like I said, this is an introduction to best practices. These are all the things that we here at GRIDSMART have spent a good deal of time out in the field and have looked at a lot of different processes and ways to do things specifically with the GRIDSMART product. And components. And so, this is all of our learning that we want to share with you and hopefully get you guys the knowledge and education that you need to have a successful experience with the GRIDSMART product. So I'm going to start with pre-installation. These are all the things that we want you to be thinking about and doing before you ever walk out into an intersection with the equipment. This will ensure that there's no surprises in the environment or in the intersection that you're dealing with that will prevent you or hinder you from having a good experience. So first, the basics. If you guys are familiar with GRIDSMART, this will be this will be known to you, but I do want to go over it because a lot of times, the easy things and the simple things we forget about, and those can cause us the most heartache. Next, we'll look at best practices, and then resources and tools, and included in that section will also be some troubleshooting tips as we go through. So there's three numbers that I want you to come away with, specifically after this slide, but just in general. And you've heard these before, but 30, 75, and 150. So for our single camera installations, we want our cameras to be at least 30 feet high. We want it to be no more than 75 feet from the center of the intersection and no more than 150 feet from the furthest stop line. This is a good rule of thumb as you look at different intersections to keep these numbers in mind, and it'll help guide you into correct camera location, appropriate camera mounting infrastructure, those sort of things. If you are mounting on a mast arm, we can't get quite the 30 feet that we like, but we can get pretty close. So you want to be, at least 25 feet, somewhere between 25 and 28 is good. The idea behind, being able to be lower on a mast arm is mast arms are generally more centered in the intersection. So we have a more head-on view, fewer occlusions, as opposed to being on a corner mount and looking across lanes or, across any type of, streetscape vegetation and things like that. The things that you want to keep in mind as you're looking at these sites is you want to locate the camera with the least amount of occlusion. Always aim for the best head-on view of all your approaches, and the camera must be in front of all stop lines. The reason behind that is at night we are tracking headlights, and if the camera is behind the stop line and the vehicles pull past the camera, then we will lose track of that vehicle and potentially miss a call. So we want to make sure that the camera is in front of all the stop lines. And I'll talk a little bit later on with the dual camera application, and that's a way that you can ensure that a camera is always in front of every stop line. And lastly, you want to make sure that your cameras are mounted on solid stationary structures. If at all possible, you want to avoid wooden poles, as they do tend to twist and move throughout the seasons as the moisture content increases or it freezes. That wood is going to shift. So you just want to be aware of that. So the biggest thing is just to know your site, right? You've got an intersection that you're looking at. One of the easiest ways to get a good overview of the site is using Google Earth. It's a tool that I use quite often. It'll allow you to do aerial views. There's a measuring tool included in there. So you can quickly gauge, is this intersection appropriate for a single camera installation or maybe a dual camera installation. You can also use it to jump into the street view and look at different mounting structures that are available, whether or not you might need a luminaire arm to install or things like that. One warning with Google Earth, it's not real time, so it may have some outdated imagery. That's why we always recommend doing a physical site survey and site visit. But Google Earth is a really good tool to get a quick overview of the site that you're considering. The next thing is the grounding, and these are all things that you can do prior to any installation effort. And the grounding is a very important part of this, as more and more communications are deployed out in our intersections. This is just going to get more important. And so I've got some things in this session as we go through that I'll talk about understanding grounding and how to test the resistance to ground at your intersections. So here's a quick screenshot of Google Earth. This is an actual intersection that we have GRIDSMART in, and I actually used this when we were first looking at it. So again, you can kind of identify where you think things would likely be in the intersection. The cabinet, again, going down into street view, you know exactly where the traffic cabinet will be. And then using the measuring tool, you can quickly determine what are my distances and, am I going to be able to do this with a single camera, or do I need to look for possibly either a longer luminaire or another corner would be an appropriate mount. So here's the site survey form. This is a tool that will help guide you through answering questions about the intersection, and as well as the GRIDSMART system that you're deploying. So it's basically going to go through and ask you a few questions about the environment, what your expectations are with the GRIDSMART. Are you looking at just doing stop bar detection? Are you looking at data collection? Are you looking at both? Is it adaptive? Do you need advanced detection? All of these things that are imperative to having the correct equipment when you go to do the installation are addressed in this form. So I encourage you, this form is available on our support site under the resources tab. And again, I'll show you some of those resources towards the end of this session. But you can certainly take a look at that form and download it and use it in your intersections. So one of the things that we've worked really hard on this year is getting out some more training videos. So I want to show you a few in this presentation just so you have an idea of what we've got. Again, at the end of this presentation, there'll be a link to all of the training videos, and I encourage you to take a look at them. They're really short, usually around 1.5 to 2 minutes, so you can get a good idea of the topic for that video.
GRIDSMART Site Survey Review. Now that you've decided to deploy the world's most advanced traffic detection system, there's an important step to take before ordering your GRIDSMART equipment. You need to conduct a site survey. Let's walk through the GRIDSMART site survey form. This form will help GRIDSMART make sure your purchase and installation go smoothly. Google Earth provides much of the information needed about the intersection. You should use the aerial, street view, and measuring tool to conduct a preliminary survey. You may also want to visit your intersection to gather the information required to manage your new system. What type of environment surrounds the intersection? Is it rural or urban? Is it flat or are there hills? What do you want your system to do for you? Stop bar detection, data collection, and how many approaches and phases are in play? The form also asks detailed information about your existing traffic cabinet. We need to know the type of cabinet you're using and the gear already installed inside. Tell us where you intend to mount the camera. How high off the ground will it be when installed? And the estimated cable run from the camera to the cabinet. Be sure to include the pole height, arm, and pull boxes in your calculations. This survey also allows you to enter information about the type of mounting pole and hardware you will use or need to complete the installation. Several options are listed. Finally, if you have images, we would like to see photos of your cabinet as well as any shots from the air or the ground that would help us ensure an easy install of your new equipment. When the form is complete, export it as a PDF and email it to your GRIDSMART sales representative, along with any pictures, and we'll get your order underway.
All right, great. And as I mentioned, that video is available on our Vimeo channel. So that link will be available at the end of this presentation, along with a lot of other videos. All right, so let's talk a little bit about grounding and the importance of it. So you're all familiar with the electrical interference, EMI. It's very imperative to have a good grounding system, especially for any digital communications and for the GRIDSMART system. So we want to look at the grounding system of the intersection. You want to test the resistance to ground at the cabinet. Make sure that there is a grounding rod, usually located inside the cabinet, with a line going up to the ground bar for the cabinet, the chassis ground. You want to test that solid copper wire there at the ground rod. You also want to test the resistance to ground at your mounting structure. So, I know that can be a little challenging on some span intersections or even wooden span intersections, but where you do have good grounding, you should be able to take the ground resistance meter and test your resistance to ground at all the points where GRIDSMART will be connected. And then lastly, you want to verify the AC ground in the cabinet and make sure that it's bonded to the neutral. The NEC recommends a maximum of 25 ohms for touch safety. And for telecommunications and digital, you want to be around 5 ohms or less for any logical reference. So here's an example of the tester. You can use the DLG 120B tester. We've used that for quite some time now. Also, there's other manufacturers. Fluke makes one. But you want to make sure you have a good ground tester for testing the resistance to ground. Again, testing it at the traffic cabinet. You can see here in this picture, we're testing the line coming up out of the conduit onto the panel. And then you also want to test the structure, as I mentioned earlier. And again, we're looking for 5 ohms or less resistance to ground on that. And this may require, in some instances, adding additional ground rods. It could be just a matter of cleaning off the contacts, removing the clamp on the ground rod and cleaning any corrosion or anything that may be inhibiting getting a good contact to ground. So I'm going to got one more video in this presentation. I'm going to start that.
Understanding grounding. In this video, we'll discuss the importance of grounding and review the instructions for grounding your GRIDSMART system. A good cabinet earth ground is important for all electronics operating in the cabinet. The NEC recommends 25 ohms or less, and the lower resistance that you can achieve, the better that the equipment will be protected from transients. Additionally, any digital communications will benefit from the reduced noise in the system that will be achieved with a lower ground resistance. To start, connect a 3 to 4 inch long piece of fine strand 10 AWG wire from the mounting pole to the mounting arm. Secure the ground wire using a self-tapping screw or a cold water ground clamp. Once installed, test the ground wire at the mounting arm with an ohm meter to ensure continuity. Then check the ground resistance at the base of the mast luminaire pole. Resistance to the ground should be less than 25 ohms. Also, if your mast arm is painted, a separate ground 10 AWG ground wire should be attached from the mounting bracket to the mounting structure. Again, your GRIDSMART system leads the industry in onboard surge protection, but if storms are a problem in your area, installing the extra surge protection is worth the effort and enhanced protection the next time Mother Nature decides to strike.
All right, so again, those videos are available on the Vimeo channel. I really encourage you to take a look at all of them. All right, next we're going to talk about system ranges, and this is all included. These next couple of slides you're going to see are a part of the intersection design guide. Again, that's a resource that is available on the support site. You can download that and use that as a reference. But we're going to look at some of those pages now. So looking at a single camera corner mount, we want to, again, look at the tracking distance of the GRIDSMART fisheye camera. So we're looking at about 200 feet of tracking radius from the GRIDSMART Bell camera. That is why we look at, when we look at the distance to the furthest stop line, as we mentioned, 150 feet. That 200-foot tracking radius gives us the ability to begin tracking those objects before they enter into the vehicle zone for detection. So just keep that in mind as you are looking at different intersections and you're measuring distances. 200 feet is about what you're going to look at for tracking distance. Again, on the mast arm mount, you have a little bit different scenario. You're going to be a little bit lower than the 30 feet that's in our spec, but you're going to be closer to the center of the intersection. And as you can see in this mock-up, you're going to have a better head-on view of all your approaches. Because you're lower in the intersection, your tracking radius is a little bit less. You're looking at around 150 feet to the edge of the tracking radius. So for dual cameras, this is where this can come into play and help you in intersections, one, that are very large, or two, you don't have appropriate mounting infrastructure to handle a single camera installation. So as you can see in this image, I've got two fisheye cameras on either corner of the intersection, and I'm using each one of those to pick up different approaches. And I'm looking at which approach gives me the best head-on view for that particular camera and gets me closer so that I have more accurate tracking and detection. For your advanced camera, what you're looking for there, if you require advanced detection at an intersection, you're going to look at about 400 to 450 feet for advanced detection. Your cameras should be mounted head-on to the approach. You don't want to have a camera that's too far off to one side and looking at a drastic angle. So if at all possible, you want to get your camera over so that you have a head-on view of the approach. You also you want to make a single zone for your advanced detection. Again, GRIDSMART is different in that we don't ask you to draw an individual zone for each lane that you're trying to detect in, or even multiple zones in a single lane. We draw one large zone over the entire movement. So that's no different on the advanced detection. If you've got a 2-lane or 3-lane fast speed approach, you can draw one large zone over all 3 lanes, and it's going to do all of your advanced detection through that one zone. All right, so this again is still a part of the design drawing, or the design intersection design guide. This is an engineering standard that you can use in your submittals, in your plans. It gives just a good overview of mounting locations for the camera, infrastructure. You can see up in the top left how the Cat5 cable would be run and come up through the mounting arm. And then on the bottom of this, it gives you the same rules of thumb as far as 30 feet high, 75 feet, from the center, and things like that. The last page of this guide shows you how to draw the detection zones. And again, we're looking at one zone over an entire movement. We don't ask you to draw multiple zones per lane. So it definitely makes the configuration and setup of GRIDSMART and the intersection much faster and simpler. All right, this next section is really important, and it's not something that we've talked a whole lot about over the years, but it is something that we've put a lot of research into. And so I definitely want to get this out to you and talk about this. But the order of operations and how the best way to install GRIDSMART, and these are the things that we expect GRIDSMART installers and distributors and customers to follow. And the main reason for that, one is we understand our system and we want you to have a successful experience with it. And it also allows us, if you follow this process, when there is a chance or during a time where you need some help, some troubleshooting, if this process has been followed, it makes it much easier for us to help you and aid you when we're trying to troubleshoot. So we'll talk about that. So the big thing is, don't waste your time on things that are easily identified. One of the biggest things that we run into are cable length and connections, and so I definitely want to get that out there. Definitely verify your cable type. Again, it's a solid core shielded Cat5e gel-filled cable. There's a specification that goes along with that on our support site, and if you need that for any submittals or reference, we can certainly point you to that. But definitely want to check the length, and the way to do that, and I'll talk about this in just a few minutes, but using a good cable tester. Also verifying the cabinet AC grounds. There's been a couple of instances where you just don't have a good AC ground. I've seen outlets wired into the light switch so that when the door's shut, the outlet's turned off because it's only supposed to be for the light in the cabinet. Things like that. If the AC ground is not connected to the outlet that GRIDSMART is plugged into, then the processor does not have a ground, and that's not good. And then also verify all the components prior to your installation. It's a real easy thing to do, and it eliminates chasing after things that you wouldn't have to. If you have a contractor that perhaps installed the cable a week or two before the turn on, and maybe there's some other construction going on there, or maybe they just didn't pull the cable well, or tight conduit and ended up breaking the cable somehow. You put the camera up, and all of a sudden you've got an installed system that's not working, and you're not real sure where to start. And if you start with testing all the equipment on the ground, then the camera's good, the processor's good, you know all of the equipment is ready to be installed, and then you can start looking at the cable or connections or any other connection points. Prior to any installation or just a site visit in general, we recommend that you visit the support site, download the latest software release that's available. Go ahead and have that update stick with you. So when you're out at the site and you need to do an update, that's one of the first things that support is going to ask you to do when you call in if you're having a problem with your site. So go ahead and have that update stick ready so we can get the processor updated to the latest version. There's also on the support site, well, actually, I'll get into this in just a minute, so I'll hold off on what I was going to say. You know, checking the cable length, the grounding, the mounting height, tracking distance, all of these things are a part of our specification. Verify that those are meeting the specification. And then only install the shielded solid core Cat5e gel-filled cable. The reason that you need the shielded, again, is because of all of the EMI and electrical interference that's out there that affects every piece of digital equipment. We are no exception. And so when you've got, you know, 300 feet of Cat5 cable running through the intersection, that's a lot of material to pick up EMI and affect the quality of our camera imagery. So you want to make sure you are using the shielded cable. The gel-filled cable, you know, this is important too because it's going to mitigate and eliminate, hopefully, any water ingress or moisture buildup inside the cable. You know, you never want to use just regular Cat5 cable. It needs to be Cat5e gel-filled, the burial grade type. On a single run from the processor to the camera, you want to be no more than 300 feet. We have a repeater available which will boost the signal after 300 feet, so you can actually use up to 2 GRIDSMART repeaters to extend the distance about a little over 900 feet. So if you do need to go beyond the 300 feet, make sure that you have a repeater available. You know, this comes into play largely when, maybe a contractor or somebody, you know, just uses Google Earth to measure out the intersection, and they determine that the cable run is not going to be any more than 275 feet. So, you know, it's good. They maybe don't understand exactly how the conduit runs, and it ends up being 320 feet. And so you really want to make sure that you're verifying your cable length. And if you do need to go over 300 feet, you've got a repeater. We have a repeater available to facilitate that. So you never want to just rely on walking it off or you know, using a wheel to measure it off. Always use the tester to validate the cable length. So here's a cable tester. I'm sure most of you guys are familiar with one and how to use it. But a good cable tester will tell you if there's a short in the line. It'll tell you if the pairs are connected correctly, and it'll give you a quality reading of the cable. So whether it's 1,000 base T or 100 base T, it'll give you that reading. Your generic continuity testers are not always going to give you the right answer. If there's continuity between the connectors, it's going to show you a green light. But the quality cable, or the quality of the cable, due to stretching or, you know, being overly stressed or kinked, will affect the quality of the images coming from the camera. So, you know, instead of using just a standard continuity tester for your network cables, you definitely use a good quality cable tester, and that'll go a long way in your troubleshooting and getting the system up and running. So the next step would be to install the EPM and the processor in the cabinet. All right. Then you want to follow that with the antenna. And the antenna is an external antenna that mounts on the outside of the cabinet. The GRIDSMART processor has a built-in modem, and what this antenna enables the processor to do is communicate to our back end and allow all of your configurations, all of the data that's being collected to be backed up to a remote site. So if anything happens to the processor, you have all of that information available and you don't lose it if there's, a knockdown or, the cabinet gets struck by lightning and toast everything in the cabinet. You have all of that information backed up in your cloud account. So all of the GRIDSMART processors ship with this antenna. The other neat thing about the antenna, it's not a single lead antenna. There is actually 5 leads on this antenna. There is a cell modem lead. There is a GPS. There is a DSRC. There is a Wi-Fi, and there is a Bluetooth. So when you have other devices in your cabinet, you don't have to drill multiple holes. So this is a real nice thing that basically just is there for you, so you don't have multiple antennas sitting on top of your cabinet. It's a very low profile. It's IP67. We actually went through our own testing and validation for any leakage, and so I can say from personal experience, your cabinet will be underwater before the antenna leaks and you have any issues with it. So, so definitely make sure that you're installing that antenna. It also will do a hourly heartbeat for you on from the processor. So, it's very easy to manage and monitor how your intersections are operating. If that antenna is installed and communicating to our back end, you can know when your intersection is having problems. So highly encourage you to be installing those antennas and utilizing the capabilities of the system with that. The next step would be to power on the processor. So inside the cabinet, one of the first steps that we talked about was putting the EPM, mounting the EPM in the traffic cabinet. This protects the camera and the processor from any surge or transients, but it must be properly grounded. So you want to make sure that you're mounting this EPM surge board away from any power distribution, and usually the power, I think, comes in on the right-hand side. You want to mount the EPM over on the left-hand side so that you don't have any interference from the power distribution coming in. Also, you want to ground the lug as close to the ground rod as possible. So you want to that'll make sure that you're getting a good ground for the EPM. And then lastly, your shield for the Cat5 cable will be connected to that same ground lug. So that's where the noise and all of the electrical interference that the cable is picking up will be drained off on, into ground through this lug. And you want to make sure that you're only grounding the shield at one end. If you ground it at the junction box where the camera is mounted and at the EPM, then you've just created a ground. You haven't actually created a drain. So you want to make sure that you're only grounding the shield at one end, and that end should be in the cabinet to the EPM ground lug. All right, next step is you want to connect your laptop and then launch the GRIDSMART client. And once you launch the GRIDSMART client, you will see the local site card. And at this point, we haven't connected a camera to the processor if you've been following along, but you will see just a black factory default site card. And the reason behind this step is the next step is going to be clicking on that site card and then selecting the info icon and verifying the version that the processor is running. So if the processor is older than the version that you downloaded and made the update stick before you went out to do the install, you'll at this point want to go ahead and update the processor to the latest version. If your client, once you connect your client to the processor, depending on the version of the processor, if this is an older install, it will tell you that you need to update your client. Newer versions of the processor will ask you if you want to update automatically. So if, for example, your client is running 6.5 and you go to install the processor and it's running 6.7, it will ask you, do you want to update your client, and allow you to download that client update directly from the processor. So it makes it very simple to update your client and move forward. The next step is you want to connect a single camera directly to the processor and verify the image. Again, these steps are in place so that you can have the confidence that everything that you're about to install, before you go to the trouble of moving the bucket truck and going up and hanging the camera and making all your connections, this will ensure that every piece of equipment that you have is ready to be installed and fully operational and good to go. Lastly, you want to install the mounting hardware and then mount the camera. So in the mounting hardware, we have a junction box that you're going to mount next to the camera. That's going to be where your field cable coming up from the cabinet will connect to the terminal block. You can see in this image here that we've got a very tight twist all the way up to the terminal block. You want to make sure that you maintain a fairly tight twist. Anytime that you begin untwisting the Cat5 cable, it's going to introduce more EMI and signal noise to those data to the data lines. So again, make sure that you've got a good tight twist all the way up to the terminal block. And then also you notice that the ground lug on the bottom of the junction box, just use a stranded number 10 ground wire and ground that to the infrastructure that you're mounting the camera on. All right, next is we're going to start configuring the intersection. So you'll select configure, and then you're just going to follow the wizard through the setup. Note, if you're not connecting, or if you are connecting the processor to your network so that you have remote access to it, from a TMC, you want to wait until you're published, after you've configured everything, and publish the intersection and make sure the intersection is operational before you plug it into your network. You can go ahead and add the network configuration, your IP address and gateway and all of that information, but you want to leave the cable, the network cable, unplugged until you're published and everything is operational. The next step is going to be to draw your road masks, and you want to do this in the fisheye view, mainly because once you flatten out the intersection, you may have areas that you want to mask that do not fit on the entire screen. And once you begin drawing your road mask, you can no longer pan the image around. So if you draw your road masks in the fisheye view, you're able to cover everything without making any changes. So road masks are done in the fisheye view. Next step will be to draw your vehicle zones. And again, we do one large zone over each movement. And then lastly, if you have objects that may cause interference with your detection zones, you can use the object mask to mask out objects such as signal heads that may swing in the same direction as a vehicle. There may be road signs or mast arms, things like that, as we track vehicles into a zone and they disappear, if there's an object mask drawn over that structure, then we know that the object didn't just disappear, but it's still there, and we need to continue making a call. And after you've done all of those 3 steps, you're going to publish. Once you're published, on the first publish, the unit will restart and come up into a learning mode. Once it's rebooted and everything is operational, you can go ahead and connect your I/O. If you're using a TS1, you'll go ahead and connect the 2 DB25 connectors to the front. If you're TS2 or ITS, then you'll connect those cables to the IO module on the front of the GS2. And then you can verify your phases and calls using the phases and calls window in the GRIDSMART client. As I mentioned earlier, if you need to go over 300 feet, you do have the ability to use the repeaters in line, and what those will do will increase the strength of the signal an extra 300 feet. And again, you can use 2 repeaters in line, so you can get up to 900 feet per camera. You want to be sure that you do connect the drain wire through the EP or through the RBA, the repeater. But when you do that, you want to make sure that you isolate the drain wire away from the repeater board. So you can use that, usually just a piece of electrical tape to isolate and protect that repeater board from coming in contact with the drain wire. All right, the last section of this presentation, we'll look at some troubleshooting. And like I said, we'll talk a little bit about resources that are available, as well as some tips that we think you may find useful. So again, as I've mentioned, we have the training videos. Those are located on the GRIDSMART Vimeo channel. Always update to the latest GRIDSMART version. That can be found on the support site on GRIDSMART Cloud. And then we recently this year, well actually late last year, released the Fresh Desk, which is our support system. We've been building out a pretty extensive knowledge base and user forum. And there's also a section in there for known issues. So if you are having a particular problem, or there's something that you don't quite understand why it works a certain way, you can go to the Fresh Desk platform and search through the knowledge base. You can read about the known issues, and if there's things that were fixed in a previous version, you may want to at that point update all of your machines if you're having that particular problem. So most issues really can be resolved by just going, following a few steps. The first one is just test one thing at a time. The minute you start making multiple changes and either things get better or they get worse, you don't really know what changed to cause either one. So if you test one thing at a time and then validate the results, you'll have a much easier time tracking down any issues that you're having, whether it's specific to the camera or the cabling or something else. Next thing is just always check the basics, right? You've got your cable tester, test the cable length, make sure that it is 300 feet or less, either between the camera and the processor, or the processor and the repeater, and then the repeater to the camera. So test each line individually and validate that you are within the specification of 300 feet. Next is always checking the grounding. If you have intermittent or no cameras, that's usually a good place to start, is looking at the grounding of the intersection. And then if you're just having problems with detection in general, using the phases and call window can help sort of guide you into understanding when this phase is making a call, is it showing up on GRIDSMART but not on the controller? It may point you to looking at the wiring and make sure that the wires have been landed correctly or assigned correctly in the controller. So if you have a problem with a no camera image or intermittent camera images, the first thing that you want to do is plug the camera into the second camera port. So the GS2, as you know, has 2 camera ports available on the front. If it is a dual camera system, you can simply swap the 2 cameras between the ports and see if the problem follows the port or the camera. And that can help identify if there's a problem with the processor or something beyond the processor to the camera. The next thing you can do using the client is under the diagnostic window, that shows all of the voltages for the system. The 48 volt power supply is for the camera. So if for some reason that 48 volts is showing 0, then you can unplug the camera, and if the 48 volts returns, then you know there's probably a short somewhere between the processor and the camera. That may be a nicked wire. It could be something in a connector. So looking at the 48 volts in the diagnostic window will help you identify, you know, any shorts or things like that with the cable. And then you want to check the cable integrity, again, using a good quality cable tester. And again, this a lot of times you'll find out, you know, real quick that, you know, the cable that was thought to be 280 feet is actually 320. And a lot of times you can, you know, find 20 feet in a pull box and another 20 feet in a mounting structure, and just be able to cut out the excess, and then you're good to go. So as a next step, you can try bypassing the EPM and plug the camera directly into the GRIDSMART processor. If the EPM is non-functional, then it probably did its job. It is there to protect the camera and the processor from surges and transients. And when it does its job, it no longer works, just like a fuse. So, even if you don't know that you've had a storm, you can always bypass that EPM and verify that you know, whether or not that EPM has been damaged and done its job. If you have one available, a second camera is useful to plug into the camera or into the processor to validate that the processor camera ports are still functional. The next thing you can do is bypass the junction box using an RJ45 coupler. So again, the junction box is a surge protector. It has a lot of surge protection built into the circuit board, and when it does its job, it will no longer work either. So bypassing that will eliminate, you know, that being a possibility for the camera not working. And then lastly, you can remove the installed camera and plug it directly into the processor, therefore eliminating anything that's in the field that would be preventing the camera from communicating with the processor. If your client is not connecting to the processor, a couple of things to check there. One, verify that the processor status light is a solid green. Once that's a solid green, you should be able to connect via your laptop. Then you want to check the client version. Again, as I mentioned, depending on the version of the processor, the client may automatically alert you that you need to update your client and allow you to do that directly from the processor. Otherwise, you want to make sure that you've downloaded the latest client update and have installed that on your laptop. And then the last thing to check is your laptop IP address. We use a DHCP, so if you set your laptop to DHCP, it'll say, you know, acquire IP address in your network settings. Then the GRIDSMART processor will serve up an IP address to your laptop, and then you'll be able to connect to it. A lot of times, I know you guys are out in the field and working with multiple devices and manufacturers, and some of those manufacturers require you to input a static IP address, and then sometimes that gets forgotten, and a lot of times that is the reason why we're not communicating to the processor. So just want to make sure you check that on your laptop. So that concludes the best practices and troubleshooting webinar, and we will go ahead and open up to Q&A, and feel free to, if you've not asked questions or if you have questions, we'll try to get everything answered. All right, so we've got a couple of questions here. We'll start with this one. So Sharon asks, we use the GRIDSMART trailer for turning movement counts. What do you recommend for detection zones to eliminate incorrect turning movements? How close to the stop bar should the zones be drawn? And do we need separate zones per lane? All right, so using a mobile trailer for turning movements can be a little bit tricky because you are going to be moving it around, and it's not usually as close to the center of the intersection as a static installed camera would be. But to eliminate incorrect turning movements, it depends on if we're looking at any sort of right channel turns where it's not an actual stop and then make a right turn, but it's more of a directed right turn channel. What you want to do with that is actually point the directional flow arrow of the zone in the direction that the vehicle will be traveling after it makes its turn. So, for example, if it's a right turn channel, you would basically have the arrow pointing perpendicular to the zone, and then you would turn on right side entry. And that would allow the system to count that as a right turn as opposed to a straight in that scenario. Let me scroll back down here. As far as how close to the stop bar should the zones be drawn, you want to draw your zones basically like you would have a loop in the road. So you really want to mimic a loop in the road, so that as vehicles travel through the lanes, they're actually traveling over the zone where we expect it to be. So you want to draw your zones just like you would in a regular a standard stop bar scenario. All right, next question from Bilal is it possible for you to create a graph like camera mounting height versus tracking radius? Yeah, there is a ratio. It's not a 1-to-1 or 1-to-10, where for every feet you get 10 feet of tracking distance. And really the reason for that is because it's a fisheye lens, the further we get out towards the edge of that fisheye, the less resolution we have, and therefore the less tracking we have. So I guess, if you follow the 200-foot tracking radius, that's going to be at 300 feet. At 30 feet. So 30 feet high, we're going to start tracking somewhere between, 200 is where I'd like to put it. But depending on the geometry and the intersection itself, you may get beyond that 200. But I know for 100%, you're going to get solid tracking at 200 feet. So that's where I like to start. So you can kind of gauge that, for every foot of height, you're going to get 8 or 9, feet of distance. But beyond, really 35 and 40 feet, that's going to start breaking down. You're not going to get, 400 feet of tracking with a fisheye. The resolution just doesn't allow for that. And that's why, that's when you would want to use the advanced camera anyway, to get that, good advanced detection further out. Okay, next question from Corey. Can you speak about the critical leveling of the camera? So it is critical to level the camera. However, the idea is that the camera is leveled to the roadway. However, that's not really feasible to do. So we do use a hand level, and you just want to level the camera out using that hand level as you're doing the install. You never want to, if you're mounting your camera over on a corner, you don't want to aim the bell camera at the opposite corner, you know, thinking, well, if I move it this way, I see more. What it's going to do is it's going to throw off all of the measurements. If you think about the fisheye lens, it's 180 degrees. So the very bottom of that lens is 0, 0. And when it's level to the ground, directly under that camera is 0, 0. And then out from that, we can look at pixels versus feet and understand how, you know, how far this vehicle is, how long the vehicle is, how fast the vehicle is traveling. So when you don't have your camera level, all of those calculations are going to be really thrown out the window. All right, next question from Tony. If you have an intersection that is an unshielded Cat 5 pulled from a previous installation, should a new shielded wire be pulled? So my response to that is, if you're having camera problems, then yes, that would be the first thing that you would want to do, is go ahead and pull shielded Cat 5 cable and replace, you know, the cable that you've got out there. If you've not experienced any camera problems or any sort of intermittent camera issues, then I would not. I would leave it alone. But again, if you have any sort of camera problems, the first thing I would do would be to replace the cable, and then also look at the grounding of the grounding system in the intersection, and test all of your ground points at the camera mount, at the cabinet, and then move on from there. Michael asked, older processors without an EPM installed in the cabinet, should we install? You know, I would say that's a good idea. You know, you likely are in a region where maybe there's not a lot of lightning storms and things like that. We have, over the years, added additional surge protection, mainly driven by different regions that experience, you know, high levels of lightning and surge and transients. And so you may be in an area that, you know, good for you that you haven't had any problems with it. But an EPM would certainly protect the camera and the processor in the event that you do have a lightning strike at that intersection. Let's see. All right. David Baker, we have had issues with shadows from adjacent lanes putting in false calls. All right, so that would be shadows from vehicles that we are tracking. One of the first thing that you need to look at in that scenario is going to be the setup of the camera. So you want to look at the north heading. You know, definitely check your latitude and longitude. Basically, we use the height of the camera, the north orientation in the client, and the latitude and longitude, and the time of day. So those four things are all used in calculating the position of the sun in relation to the objects that we're tracking through the intersection and the shadows that those objects will be casting. So you want to check all of those parameters in the intersection, in the setup, and make sure that those are correct. And then if that doesn't solve your problems, one of the things that GRIDSMART has always enabled users to do is plug in a USB hard drive and record data. And we use that data to continuously improve our algorithms. And this would be a great thing to use that for, if in fact it's not a configuration issue. But that would be my first thing to look at, would be, the north heading and all of the camera settings, and make sure that all of that's configured correctly. So another question is, does it matter in what order you draw the zones and the masks No, it doesn't. I've just found that, you know, drawing the road mask, when you first launch the client and click on the site card, the first image that you're going to see is the fisheye. And so it's easy to just draw the road masks then. Once you draw the vehicle zones, then you can look to see, are there objects that may affect, you know, or cause any false calls with the detection zones. You're more than, I mean, you can certainly mask out absolutely everything that is between the camera and the roadway. You know, like, you know, any luminaire arms or things like that. You want to mask all that out. So it really doesn't matter if you draw the object masks first and then draw the vehicle zones. You know, like I said, I just, I guess I usually draw the vehicle zones first, and then I really look, is there anything that's going to affect the operation of that vehicle zone that I need to use an object mask for? And then, you know, the object mask is not just for vehicle zones. It's also if you've got, you know, for example, you know, the camera may be mounted right above a luminaire head that's white, and in the middle of the afternoon, that whiteness is going to, you know, bounce back up into the camera, and we're going to use that whiteness to modify the white balance of the image. So you would use an object mask in that scenario to mask that out and prevent it from affecting the camera. Okay, so we have another question. What should be the maximum mounting height for the Bell camera? You know, there is a point of diminishing returns with the Bell camera. The higher you go, the smaller the objects that we're tracking are going to be. I would say we don't have a definite or a defined max height, but anything over 45 feet is probably not going to give you any better detection or tracking. So, you know, I would say, you know, 45, no more than 50 feet. I know, you know, we've got some that, you know, are doing some roundabouts, and, you know, 50 feet is working fine. So 45 to 50 feet, anything over that, I think you're going to be tracking ants. All right, let's see, another question. Can you make a PDF available for, yes, for these slides? I will certainly make this presentation available to the attendees and make it as a reference for you. All right, looks like, okay. Looks like that's all the Q&A. Again, I really appreciate your time. I hope that this was informational. And let's see, one last question. We do have, does GRIDSMART work with roundabouts? Yes. So yeah, it's actually, you know, a pretty cool thing with the roundabouts. You know, with the fisheye camera, you can see an entire roundabout with a single camera, where, you know, any other camera, I don't know how many you'd have to see a full roundabout, but it'd definitely be more than one, and maybe less than 12. I don't know. But you can use the fisheye for a roundabout. One thing that, you know, you need to be careful of is if you have the camera on the side of a roundabout, that makes it very difficult for tracking. If you can put the camera in the center of the roundabout, and again, you know, trying to get up around that, depending on the size of the roundabout, if you're able to get up, you know, 40 feet, that gives us a really good view of the entire roundabout, and we can work really well in that scenario. Let's see, another question we have. The newer processor, the fan is extremely loud. What is the fix for this problem? So the fan is controlled through a thermostat and via software in the processor. So when it's really hot, that fan is going to kick up. I think there's 3 modes that fan runs in. And if it's really hot in the cabinet, then it's going to be working overtime to cool off, the processor and make sure that it stays happy. So it may run at full speed depending on the the region that you're in and the temperature that you're dealing with. The other times that it will run at full speed is during an update. If we do a firmware update, then when the processor is finishing the update, it will stop controlling the fan, and the fan will run at full speed until the unit has completed the update and rebooted. So that's really a good way to test that. I mean, if you do have a hot cabinet, it's going to run pretty hot, or pretty loud. But it should only otherwise do it when you're doing an update. All right, guys. Again, thank you for joining, and we will. If you have any questions, feel free to email us and drop us a line. And thanks again.